Hello class. In this video, we explore the concept of diagonalization. Now, I'm sure you may have come in touch with this concept, and you may ask yourself what diagonalization is. So, considering n times n matrix, which is a square matrix A, this matrix will be called diagonalizable if we have P minus 1, the invert, times A times P is diagonal for some n times n matrix P. Okay, let's have a deep look on this by exploring some theorems. Now, the theorem 1, right, says that if you consider an n times n A matrix, right, A is diagonalizable if and only if it has eigenvectors v1, v2, vn such that matrix P equals to v1, v2, vn is invertible. Okay, if this is the case, therefore, we have the second point here, therefore P minus 1 AP is diagonal of the eigenvalue of matrix A. Now, these concepts are very important for you to master. Now, let's look at the second theorem. Theorem 2. Theorem 2 says that a square matrix, n times n matrix A, is diagonalizable if and only if its eigenvalue lambda of multiplicity m yields m basic eigenvectors. Simple as that, right? And the last theorem, which is not the least, the theorem 3, okay, says that a square matrix m times n, a square matrix A m times n will have is diagonalizable if and only if it has n basic eigenvectors. Right. So we just explore the definition of what diagonalization is, and then we touch on the first, second, and the third theorem that will help you to grasp the concept of diagonalization. Now, you may ask yourself, how can I prove that a matrix is diagonalizable? Now, we have that diagonalization of a matrix A. So let's look at the algorithm, right? So the first step here will be, right, to find the distinct eigenvalue lambda. You know how to do that by solving the equation determinant of A minus lambda I equals to 0. The second step will be, okay, to find the eigenvectors corresponding to the various eigenvalue you found in the first step. So we have that, and you find the eigenvectors. How? By solving the equation equals to 0. And here at the third step, right? Here at the third step, you have to check, right? You have to check if your matrix A will be diagonalizable, and how do you do that? You have first to check the multiplicity of lambda, right? And then you also have to check that the n times n matrix, right, will yield n eigenvector, right? And then the eigenvalue, remember the second theorem that we use, the eigenvalues lambda of multiplicity m should yield m basic eigenvectors. So you check out these two theorems now, and if that is the case, you can now move on to have your matrix P, right, which is the matrix of the eigenvector of A, which is be Vn, V2 dot Vn, and P be invertible, right? And then you can also prove that your calculations are correct by proving that the invert of P times AP is diagonal, equals to the diagonal matrix, which is simply lambda 1. We are considering a let's say 0, 0, 0, 0, lambda 2, lambda n, 0, 0. Okay, so in this video, we defined the concept of diagonalization. We show you how to diagonalize a matrix and what are the theorems that will support this exercise. Now, in the next video, you'll be exposed to more practical exercises where together we will be answering the question to diagonalize a certain matrix. Thank you very much.